In this video, I'm going to work an example around right triangle trig. So there's a how-to up there. I'll let you guys read that if you'd like. I'm just going to work the problem. A right triangle has one angle of pi over 3 and a hypotenuse of 20. So, okay, right triangle, I'm going to draw one. Right, here's my right triangle. And it says, as an angle of pi over 3 and a hypotenuse of 20. And then let's call this side x and y. And we'll call this side that angle beta. We have to find, it says find the unknown sides and angle of the triangle. This is also called solving the triangle. So if they say solve the triangle, that's what they mean. Find all the sides and the angles. All right, so I can use some trig here. I see that I have a pi over 3 there at that angle. And I'm going to use sine first of pi over 3. And we're going to use this to find y. Sine, remember, is opposite over adjacent, or hypotenuse, opposite over hypotenuse. So I'm just going to fill in the sides. Opposite in this case is a y. Hypotenuse is a 20. Well, we can solve this for y. Notice it's an equation. I could just multiply both sides by 20. So that means y is equal to 20 sine of pi over 3. Now sine of pi over 3, okay, sine is y. It's my tall triangle, so that means it's radical 3 over 2. So my answer is 10 root 3. If you need help on this, go back to some previous videos. We can draw a triangle. It's in quadrant 1. It's the tall triangle, and then sine is y. That's why we get radical 3 over 2. So that's y. We can do the same thing for x with cosine. So I get cosine of pi over 3 is equal to x over 20, right? And we can do the same thing to find x, right? Multiply both sides by 20. Cosine of pi over 3, it's the tall triangle. Short side is the x, so this is just a 10. So y is 10 radical 3, x is 10. To find beta, we just take 90 degrees. Rather than 90, we'll take pi over 2, because that's 90 in radians. And we're going to minus the other angle, and that's going to give me a pi over 6. You can just common denominators, or if you've known from the previous videos, pi over 3 and pi over 6 make the 90 degrees. It's just a good thing to know. All right, so that's just using just a straight triangle. We can actually use this kind of triangle math in applications, usually with lines of sight. If you see people out on the sides of the road with that tripod with the usually yellow like box on top, these people are using right triangle trig to figure out distances and heights and find the grade, or how much does a street go downhill or uphill. Okay, we have a couple definitions here. There's a box of how to. I'm going to leave that there because if I read it to you, it's not going to mean anything. The angle of elevation, right? We've got to be careful with these definitions. The angle of elevation of an object above, so that's the key word here. You're standing somewhere like down here, right? There's my person, right? Standing down there and you're looking up at the top. Well, the angle from your horizontal up to your line of sight is called an angle of elevation. Elevation comes when you're looking up at your object. Okay, the angle of depression is if you are looking down or below at an object. So that would be like you standing at the top of the tower here and looking down. Well, from the horizontal, this is the part that people mess up. From the horizontal down to your line of sight is the angle of elevation. So if I were making a triangle here, that angle, like here's my triangle, that angle would not tell me the angle of the triangle, tell me the angle outside of the triangle, but I know that angle and the angle inside the triangle make up 90 degrees. So the angle of depression typically will just give you a little bit more, you'll have to do a little bit more work than the elevation. Elevation usually will make the triangle. All right, that cut the sentence off, sorry. To the observer is the angle between the horizontal and the line of the object, from the object to the observer's eye. So line of sight. Right, so we're going to draw a picture. That's my favorite. That's my highest priority here, is draw a picture. It's going to help, and we know what trigonometry is going to be focused around, triangles. So we're trying to make a triangle. So how long a ladder is needed to reach a windowsill 50 feet above the ground if the ladder rests against the building, making an angle of 5 pi over 12 with the ground. So here's my ladder leaning against a roof, and we knew it was going to be a triangle. It didn't make one for me. Still not. Okay, I'm struggling here. I'm trying to make it smaller maybe. Oh my gosh. Usually it does it right away. There we go. Okay, so here's my right triangle that I just messed up. So the right triangle is going to be, says 50 feet above the windowsill. And then they also said that this angle is 5 pi over 12. And they want us to find how long a ladder is needed. So we are needing this distance here. I'm going to call R because that's what we're used to. Well, I can see that I have an angle, and I have opposite, and I have my hypotenuse. So this calls for sine. So sine of 5 pi over 12, and you notice that's not in our unit circle, is 50 over R. So I can find R by timesing each side by 50. And then this is just going to be a calculator problem. So you'll type that in. Let me see if I can pull my calculator up without disturbing my video too much. Cool. Do that. And I'll type this in. Okay, you got to make sure it's in radians. So I'm going to make sure my calculator is in radians. It is. And I'm going to do 50 sine of 5 pi divided by 12. That's going to be a roughly 48.296. We'll leave it there. And we're talking feet. You should do a rational check with this. It is rational that it could be 50 feet, around 50 feet, because the height of the building is also 50 feet. 5 pi over 12 is really close to pi over 2. One more unit, one more 12th would be 6 over 12, which is straight up and down, which means my ladder is going to be pretty steep, which means it's also pretty close to the actual height of the wall, meaning because it's steep. All right. Another picture, another problem like this. Child is holding the end of a 38-meter string attached to a kite. The string has an angle of elevation of 81 degrees. Determine the elevation of the kite. Give your answer rounded to the nearest whole number. Okay, so I draw my triangle. Hopefully it'll draw it this time. Yep, there we did. Okay, child is holding the end of a 38-meter string. So if the child is down here and the kite's up in the air, that's 38 meters across there. This is a right triangle that I can draw. The string has an angle of elevation of 81 degrees. Right? And it says determine the elevation of the height. So that's going to be the height here. So I'm going to put an R. I guess let's use something that's not going to be on the triangle. Let's put an M. All right, so if I'm looking at M is opposite of my angle and I have the hypotenuse. This calls for sine. So sine of 81 degrees is equal to M over 38. This equation can be solved by multiplying both sides by 38. So I get M equals 38 sine of 81 degrees. And then now this is just a calculator problem, but you got to make sure you go back to degrees or 2 degrees. And I got 38 sine of 81. And that gets me roughly 37.532.156.942.62. And this is meters above. And you should do a rational check. It's 81 degrees. That's pretty steep, which means the ladder is probably about the same height as that. All right, cool. Pretty good rational check there.